Okay, so we are inside RStudio Cloud now, and we can go to the our workspace before. Okay, our workspace that we did before. And so so here what I can see here on my screen is the previous projects that we have done. So for example, if I click multiple logistic regression, then I can restart the work, or I can resume the work, right? So I'm thinking if we should create a new project or not. By right, we should lah. Okay, by right, it's a good practice to always start a new analysis, a fresh, brand new analysis on a new project. Okay, so at the same time, I should be I should be able to see. Oh yeah, yes. Boleh dengar?
Boleh.
Yeah, siapa tadi yang hello tadi? Siapa yang berhello tadi? Okay, tak apa. All projects, so I should be able to see Hidayat, Nabila, Ikhwan, Zulfahmi, Tengku, Muhammad Fakhruddin dan bla bla bla. Okay. Nur Akmal dah ada icon something there, which is good, right? Okay, so never mind. So we go back to this one and let's start a new project. Okay, let's start a new project because this is something new. We have not done anything before, brand new. So we start with a new project. Okay, untitled project. Okay, dia tengah start tu. Jangan tengok saja. Amir tak dengar? Yang lain dengar ke?
Dengar.
Boleh dah bro, boleh dah.
Okey.
Okey. Aduh. Amir. Tak apa malam ni. Lawan Leeds United. Malam ni Leeds United, okey? Jangan bimbang.
Buat predictor bro.
8-0 lah, lebih 1 pada Liverpool.
Jadi
Okey, saya baru bagi data pada Ikhwan. Data tu pun saya sudah ada dalam kita punya e-learn, tapi saya tak sempat check semalam. But I've given to Ikhwan. So ada dapat nanti share tu. So yeah, now we are in a new project on RStudio Cloud, R4.0.3, codename Bunny One. Bunny One is freak out. Okay, Bunny One is freak out. Okay, so we can upload our data. Okay, upload, choose file, and then alamat keluar gambar pula. Okay. Right, where is statistics? Data, stroke outcome data, open, and then okay. So stroke outcome data is now inside our project directory. We can put this the project name as whatever lah, stroke analysis, for example, stroke survival analysis. Right. On the your computer, if you have and open up your RStudio, and I've got a different interface because this is RStudio preview. Okay, so I have three columns. Okay, but doesn't matter. Okay, doesn't matter. So whenever you want to start a new project, a brand new analysis, never been done before, then go to File, New Project, New Directory, and then New Project, and then you may want to browse and put inside your document, or I like to put inside OneDrive. Okay, OneDrive, because by doing that, I can link automatically with OneDrive, USM OneDrive. So so it is it's a security lah, double protection, so that if anything happen, I'm still I still do have a copy on the cloud. Okay, so okay, just make an example for the as survival. Okay, open. Oh, so this is what okay, open, and then test survival, create project, and then it will start new. All right, what it is important is to put the data set in the this what we call files pane. The file pane, you will see, let me enlarge this. In the files pane, you should place your data set here, but you can't do copy paste here. It doesn't work. It doesn't work. So what you need to do is you go back to your folder. Okay, and then copy. For example, you download the file, and then search for the project that you created just now. Okay, should be this one, test survival. Then paste, and then you see paste data here, stroke outcome DTA, and at the same time you will see your data is visible inside the project directory. Okay, good. Right. So, but I want to work with RStudio Cloud, so I'm gonna close this RStudio, or maybe just leave this open. And coming back to RStudio Cloud, we have a data set here, and then what we want to do is now we want to code. Since I always prefer R Markdown, then we are going to create a file, new R Markdown file. Okay, and then it will ask to install some packages, which we will say all right. So creating R Markdown document require updated versions of the following packages, blah blah blah. Do you want to install? Yes. All right. While it is installing, let's go back to the node, and what we are going to the notes again have the short practicals and the long practicals. The short practicals, the short practical is the practical that you should be familiar with lah. Okay, if you know everything about the short practical, quite comfortable with that, you might you definitely will pass the exam. Maybe will not get 70%, but maybe almost there lah. 65, maybe around that. Okay. If you add some additional things, then you might get 70% over 70%. But if you know the long practicals, then quite comfortable with the long practicals, then you can expect your marks to be around 80, something like that. 80%, 90% maybe. Okay. I think that's fair lah. Okay. Document, coming back to RStudio Markdown, I want to title this as my survival analysis. Survival analysis is also known as duration analysis. Okay, duration. Okay, right. Okay, so we are going to okay, the flow of this is that we're going to load libraries because libraries are important for us to work with the analysis. And then we are going to prepare our data. Then we are going to deal with dates. Okay, dates are something quite important in survival analysis, because we need to, the duration, the variable duration is the difference between two dates, right? For example, date admission, date of discharge. So so if data comes with days already, like 5 days, 10 days, 7 days, 25 days, already someone did that for you, you are lucky lah. But sometimes you have to calculate manually. Okay, calculate manually. The problem is that Excel, for example, when you import Excel into your software, the date can be haywired. Okay, because because in the data set, this person will enter data this way, that person enter data that way, and because of that, you got mix of style for dates in the Excel data, and when you read into SPSS or Stata or R, for example, then it becomes haywire. Okay, again, there is another argument why Excel is never a good choice for data entry. Right. So so we're going to load some libraries, prepare data, deal with some dates, and do Kaplan-Meier. And then after that, we'll do proportional hazard regression. And we are going to do some interaction in the model and do model comparison before we go to the long practical. So I'll spend only the short practical. The long practical too, you can do on your own. We are going to load library Haven. Why? Because Haven is a package that help you to read statistical data from SPSS, data from Stata, data from SAS, and also data from, I forgot one more, I think 3 or 4 software. So library Haven can do that for you. Library Tidyverse is a general package for data wrangling or data transformation and data visualizations. Lubridate is a package that deals with date. If you have questions about Lubridate, you can ask Afika. Okay, she's good at Lubridate, and Tidyverse. You can go and ask Hidayat. Okay, so there are 2 resource person that you can go to. Survival is the package that we are going to use. We are going to load to run a survival analysis, and Serve Miner is a package for us to visualize survival results. Okay, and library here is just a package to help with the locations of the of your files. So not that important, okay? So we are going to copy this, right? Gonna delete this and we just leave the upper portions of the R markdown, and then I'll make the first heading as load libraries, and then put our code chunk either by Control Alternate I or click Insert R, whichever way you are comfortable. For this example, I'm going to click here. Then you see this R code chunk. And then I'm going to paste this library heaven, library tidyverse. What else? Library lubricate. Copy. And then what else? Library survivor and library serve miner. Okay. Here is not necessary. I don't have to load it. So I'm going to run this. So what do you expect? You will expect that RStudio will ask to install some packages because we have not installed these packages yet. So RStudio will ask the permission to install these packages. So I'm going to run this, and it will say, error library heaven, there is no package called heaven. Okay. So doesn't matter, no problem. So I'm gonna go to packages. I'm gonna install heaven, install. Okay, it takes some time to do that. Right, install packages heaven. Okay. Okay, now I'm gonna install tidyverse. So it takes a while. Okay. Tidyverse is quite a big package. Okay, coming. All right. So let's activate heaven. Okay. Okay. Now it's all right. Let's activate tidyverse. Load tidyverse. All right. I just wanna see what so you got ggplot, jibber, tidyr, per. Okay. I still need to install a lubricate. Okay. Install lubricate. Do you want to restart, brother? No, I don't want to restart it. Survivor you don't have to install, okay? Because Survivor is already inside inside R. Okay. So we have finished installing Lubridae. We are going to load this. So Ctrl Enter. Okay, works. Survival, right? See, there is no error. Okay, because survival is already there. You just need to load it. Okay, you just need to load it. How about Savannah? Savannah you also need to install. Okay, Savannah. Mana nak keluar? Tak dapat nak keluar pula. Okay. So how to right. Okay. Okay. Right. So serve minor, Ctrl Enter, load it. Okay, now no more problem. Okay. So we read our distro outcome data. Since it is data, so we use read underscore DTA. Okay. And we are going to name this as my data. You can put whatever name you are comfortable with. So we're gonna read data and click the green button or Ctrl Enter. So now you will see my data in the environment pane. You can click on this data and you can see the tabular form of data, registration number and variables. Okay, right. So what else? You can do glimpse, and if you do glimpse, you see that some variables, for example, like this one, race to hypertension and diabetes and event is a double variable. You see here is written as 00011100101, but actually it has something that 0 means something and diabetes DM20 means something and 1 means something. Hypertension 0 means something, 1 means something. I also don't remember this, right? So that's why I prefer, rather than code as number, you code as the actual character of the variables. So I can, what I need to do is to convert this 010101 to factor variable, right? To factor variable. So I can do like this. Okay, or I can be quicker if I do this, I say to my data, do this. Do what? Mutate or create or convert all variable that is labeled 1, 2, 3, 4, 5, 6, all 6 of them, and change them to factor variable. So if you have 15, 20, 30 variables that are label variable, you can use this short function, just one line. You can convert 30 variables in one shot. Okay, so I'm going to copy this So across it means that, okay, look at all the columns where the variables are labeled variables. Okay, that's what we meant here. Okay. Okay. So now if you click this one, click the data set, you see that now instead of you see 0101, you see female, female, male, male, race, Malay, Malay, others, Malay, Malay. So it is much easier for you if you have this kind of data visible to you, all right? Even though I know that we have sort of trained to use 0110 123 to label our data, but I think this is more clear cut, right? So we don't have to tell anyone that, okay, remember that yes.
Oh, tapi ini yang command ni untuk kalau dia daripada starter punya label je kan. Yang
Betul.
command yang putih ni. Yang lain tu basically tak boleh kan kalau guna command ni.
If data comes in CSV or Excel kan, so if the file to datang like this 01, then there is no way of converting that using this lah. What you need to do is you use mutate, and then you have to use this one lah, S factor, and then then you have to give value. You have to type C equal what? For example, you have diabetes. DM2, 0 is no, 1 is yes. Then you have to do manually like this. It means that you have to write S factor, my data at DM2, comma, C, no, comma, yes, close bracket, then close it again. So by doing that, it will change the value 0 to no, 1 to yes. Okay, so you have two options, either to do that in R or to do that earlier in Excel even. It means that, dalam Excel tu, you replace 0 with yes, 0 with no, for example, or 1 with yes, whichever code you are using lah. And then after that, baru read into R. Okay tak, Ikhwan?
Faham.
Ikhwan ke tanya? Ikhwan kan?
Ya, betul lah.
So kalau you don't want to pening kepala with R code, then you can do that lah. Treat handle all the data cleaning, everything in Excel. Then baru tarik to R. The problem is that when you do that, you it's very difficult for myself. For example, if I'm your supervisor, right, and I don't see what you have done. I don't see how what you did to your categories, how you convert your categories, how many groups you collapse, how many groups you change name, because that was done in Excel. Faham tak, Ikhwan? So the benefits of checking, or the advantage of or the informations about how you do data wrangling itu is not clear to me lah, because you did that in Excel. So that is one drawback lah. If you in the orang kata apa, in the reproducible report ataupun in reproducible analysis, that is something that we want to avoid lah. We don't want you even to clean your data inside Excel, because we miss that. We miss the step. We don't know the step that you have taken to wrangle or to transform your data in Excel. Okay. And if we want to reverse, we can't do that, because you already, did that in Excel. Okay. So not difficult lah. Okay, just Google how to change how to label factor variable d player. Okay, d player, and so which is you got factor recode and factor, just quite easy. Okay, not that difficult. Right. So come back to this, and then you can use summary of your data to see, the summary of variables for male, female, race, blah blah blah. And this is where we have a date of admissions and date of discharge, right? Date of admission, date discharge, and we don't have duration. We don't have duration. Okay, we don't have duration. We have date of admission and date of discharge. Date of discharge in this case is considered as the end of the study. Okay, and the event here is coded as 0 and 1. Okay, 0, 0, 0 means sensor, and 1 means that is event. Okay, but here we still have to do something. Okay, because ada dekat sini the event. Okay, event censored and censored is 0 and 1 is date. Okay. Okay, what else? Event. Okay, censored. We have 199 and date is 63. Okay. So because censored is shown earlier, so censored is 0 and date is 1. So no is 0, yes is 1. No is 0, yes is 1. That's another way of knowing the coding of the variable. Okay. Race no is 0 and yes is 1. So I think this one is Malay, non-Malay, I think. Okay. Right. So we are going to to create a time variables. Okay. A time variable where we generate a new variable called dur or duration or time, whatever, where it is a difference between date of admissions and date of discharge. Date of admission and date of discharge, and you convert this as duration. So there's involved 3 steps. 1, 2, 3. Okay, first, generate a new variable named duration, the difference between the 2 dates, and then you declare this as duration, and then you generate a new variable called dur days. So you should see 2 new variables. Okay, 2 new variables. We try to do this first. Okay, copy. Right. So we are going to see a new variable called dur. Okay. In fact, I can just do this. I can just do this. Where is dur? Dur should be the last one, I think. Okay, this is interval. So it's something cryptic, 2012 UTC something. So that's why you need to convert this to as duration. Okay, as duration. So if I do this, then it becomes 518,400 seconds, which means it's around 6 days, around 5 days, around 2.57 days, 3.29 days, still 3.29 weeks. Okay, still a bit cryptic, right? So don't worry, we do this, okay? We do this first, okay? We do this first, okay? And in fact, we go to my data, you see at the end of this, you see this 51,518,400 seconds. Very, very exact, okay? Very, very exact. Then, we want to change this to days, okay? We want to change this to days. There is ways to change to days. There is ways to change to week. There is ways to change to month, okay? So what I'm interested here in days. So I need to use this formula. You need to read the manual for in the Lubridates package to see how can you convert this. You can even convert to epic week, okay? Epic week 1, 2, 3, and 4. You don't have to manually calculate this epic week 1 or epic week 2 or epic week 3. No need. Lubridates can do that for you. So and I can just put it here actually. So now if you go back to your data, and at the end of it, you will see that duration now has been changed, or is now changed to 6 days, 5 days, 18 days, 23 days, 3 days, so on and so forth. All right. So now we have complete data. We have time. This is variable time. Okay, in exam I always got this, where is my time variable? Where's my time variable? This is your time variable. Okay, this is your time variable. 6 days, 5 days, 18 days, 23 days. This is your time variable. Okay, and this is the event variable. Okay, event here is coded as censored and date. Okay, censored and date and censored. Okay, date is one. So date and censored. So you don't have to remember 0 and 1. It's date versus censored. Okay, right. So remember, this is not 0 and 1. Okay, this is not 0. This is no longer 0 and 1. This is now date and censored. Okay, remember, because next we'll come to this. Okay, not 0 and 1. This is censored and date. Okay, right. So when you see here, this is the Kaplan-Meier estimates. So the functions for Kaplan-Meier is serve fit, and then serve. Okay, this is a code, to declare that your data is a survivable data. Okay, how we do that? We write a function serve time. Variable time is due days, and variable event is that variable name event, which is labeled as date. Okay, this is variable time, this is variable event. Variable time in our data set is named as due days. This is our variable time, but it is named as due_days. So that's why it is due_days. And variable event is in our data set named as event also, same. Okay, event. But the event of interest is not censored, it's date. Date, okay? Remember date here. So that's why I need to put equal apostrophe and date, or parenthesis and in between date. Okay? Very important. Okay? Very important. And then tilde 1 and type Kaplan-Meier Basically, that's the default of the Kaplan-Meier estimates in R. And data, which data? My data. And I'm gonna save this as KM1. So let's create another chunk. So let's make a new heading. So analysis. Ctrl V. Panjang sikit. So bagi cantik sikit. Okay. And then run this. So KM1 now is an object here. And then I can look at the results. Then I'm going to put the code to view the results. I'm going to type summary summary of KM1. So this will tell this will show the the results of the estimates from the Kaplan-Meier. This is at time 0, at time 1 day, at time 2 days, at time 3 days, 4th, 5th, 6th, so on and so forth until 41 days. And we have 262 at baseline, and at day 1 we have there are four event, okay. And after that we have censored also here, and then the 250 time 1 day we had 256 at risk, and out of 256, 13 died. So the survivor is 0.935. Okay, we can try and confirm this copy, and let's do this. 13 divided by 256, which is 0.5, which is different. 0.05. Now I got a calculation. Okay, it's a little bit okay, let's see. Let's do this. Let's do 4 over 262, which is 0.015. 1 minus this one, Ctrl C, Ctrl V, which is 0.9847, which is this one. Okay, which is this one. And then we have 13 divided by 256, and then we want to 1 minus this one, so 0. Let's see if I got this right. Okay, Ctrl V, and then times this one, Ctrl C. We have 0.934, which is this one. Okay, the probability, survival probability of this and this. So because of that, you have to times this. Right. Yeah, I've got this calculation here. And then after we have, we got this survival, we can plot. Okay, we can plot this, which is quite easy. So we say now plot survival, and to plot this I use ggserve plot. Okay, ggserve plot. And which data my data, and risk dot table is true. You can change to false and see what will happen to your plots. Okay, copy, Ctrl V, and so there you go. You can see it's a bit smallish. Keluar ke? Tak keluar ke? It doesn't want to come out. Okay. apalah, tak nak keluar, okay. So don't worry. Right. So this is the overall, okay, overall survival probability. So you have, we start off with everyone alive, and then after that, some patients die and die and die and die. So it does not come very well here because of the limited space. So you might want to do some adjustment, or maybe in on your computer it looks much nicer. Okay. So good. And this is the confidence interval, 95% confidence interval of the survival probability. And now let's say we want to see the survival, because this is an overall survival probability. Okay. So we want to see the probability based on sex. So we want to see for male and for female. So we will expect this kind of result, sex male and sex female. And this is time, and this is number of risks at that point of time, and how many developed events at that point of at that cohort. So gonna do this. So we say comparing groups sex. Okay. We run this.
Yang
So
yang
you got
macam
this,
dot rank Prof.
No, this not yet. This is descriptive, baru descriptive. Still descriptive, okay? Not yet log rank, okay? So then we can also view this. So that so when you choose GG subplot, you choose km1.g because you want to plot this one, not this one. All right, this is km1. This is km1_g. So km1.g. Okay, so this line type 3 and 6 will generate this dots and dash. So you can play around 4 and 8, 1 and 2 and see what will happen to your plots. Okay. And I also put p-value here, p-val equal true, and this is the p-value, and yes, this is the p-value from the log rank test. Okay, this is the p-value from the log rank test. This one I make a very basic survival plot, no p-value, and only one group, the whole group. And but this one I split into 2, and now I can when I plot it, I can put the p-value and get the log rank test value. So copy this and plot and compare. So it show you the blue line is the survival probability for female, and the red line is the survival probability for male. Overall, you look at, there is not much different, right? Not much different, except for this one guy, a female, which is survived for a very long time. But I think he was discharged alive. He was discharged alive up 60 days, but at the end discharged alive. But not sure lah how alive is alive lah. Okay. So the p-value is 0.41, which confirms our intuition that there is no difference in the survival probability from stroke between male and female. Okay. This is the survival time. Okay, survival time for 25%, 50%, and 75 percentile, along with the 95% confidence interval. So you can type quantile and props 0.25, 0.5, 0.75. You can put 0.8, 0.6 if you want to know the survival time at that particular time. Okay, so right, so let's go back to here. Estimated time for specific probabilities. Okay, so we want to look at what will be the estimated time where 25% of the cohort died. What will be the estimated time when 50% of the cohort died, and what will be this estimated time when 75% of the cohort died. So when 25% of the cohort died, the time taken for that is around 7 days. So yes, 7 days. 25, between 6 to 12 days, 95% confidence interval. 50%, okay, if you look here, 50%, okay, 50% here. You go straight, and then pop there, and then must be here, right? Somewhere here, 20 something days, right? 20 something days. So if you look here, 50%, yes, 22 days, right? 22 days, and 95% confidence interval between 12 to not available, okay? Cannot be estimated because why? Because we don't have enough data to extrapolate, okay? So that's why coming up with not available. But the lower bound we could estimate quite confidently. Right, now this is the log rank test. So when we observe this one by our naked eyes, so we thought that, you know, for example, we look for sex. If we run this, okay, even with naked eyes, we say that there is no difference. The survival probability looks similar in male and in female. So even if we do log rank test, which is serve diff, okay, serve diff, my data and row here equals 0. Okay, row equals 0 is log rank test, row equal 1 is something else. I forgot already. You can look at the manual. So we now say, okay, I want to comparison of survival which is 0.4, okay, which is 0.4. So there is no difference in the observed and expected survival probability in from stroke in male and female. And in fact, this is the same as the p-value that we see in the plot. So yes, this confirm our intuition based on our naked eyes examinations that there is no difference in survival probability between male and female from stroke. Right, so let's go to a Cox proportional hazard regression. So let's start first with model with no covariate. Okay, no covariate, just, you know, just nothing there. Okay, not just nothing, they're just constant. So we use the function Cox pH, and then this is the code to declare that our data is a survival data. Pay attention to time, and this is variable for time. pay attention to event. This is the variable for event, and this is the event of interest. 1, 2, 3. 1, 2. Okay, and then 1. I will not run this. I just go straight to adding a covariate. For example, I want to estimate the relationship between Glasgow coma scale and the hazard of dying based on Cox proportional hazard regression. So I use the function Cox pH, then declare the variable of interest. Time is due days, event is event variable, which is date that I'm interested to predict, and GCS as the covariate. And I'm going to name this as cox.gcs. So let's so now build estimation using Cox proportional hazard regression. So even right, everything looks good. So this will give you will return you the summary here, return you the model for Cox .gcs. The name of the model you give here is cox.gcs. So from the model it says that there were 262 observations where 63 of them died. Okay, and this is the beta. The beta is minus 0.22. It means that with 1 unit increase in GCS, the log hazard, okay, the log hazard changed by a factor of minus 0.22. Okay, so if in the population the GCS of the patients is 1 unit higher, then the log hazard decrease by a factor of 0.22 or 0.23 lah. Okay, so you can
Prof, kejap, Prof.
yeah.
Kalau dalam bahasa Melayu dia makin kurang GCS ni, sebab ni kan negatif depan, kalau makin kurang GCS hazard dia makin tinggi kan? Sebab dia tadi Prof kata kalau dapat increasing tu betul kan?
Yeah, tapi yes. So that's why lah. I mean, tapi yelah, cumanya kalau kita ambil data tu kalau kita ambil dekat sini, bila kita interpret tu, kita interpret always in the increasing lah kan. If GCS increase by 1 unit, then sebenarnya sama je kalau GCS tu dan turun, then coefficient tu akan jadi tukar balik lah kan. If GCS reduced by 1 unit, then the log hazard changed by 0.23. If GCS increased by 1 unit, then the log hazard changed by minus 0.23. Okay. Yes. Okay. So and in this result, the author of the package also give the exponentiations of the coef. So the exponentiations of the coef, which is this one, what does this mean? This is the hazard what?
Ratio.
Hazard ratio, which is the apa ni same formula with odds ratio, right? When you exponentiate the beta value. So if you want to interpret this then if the GCS is 1 unit higher, then the hazard of dying decrease by 21%. Or you can interpret as if GCS is 1 unit higher, then the hazard to die changed by a factor of 0.79. Okay. What else? Okay. And but there is no 95% confidence interval. There is a 95% confidence interval below, but that is the 95% confidence intervals for the hazard ratio, not the 95% confidence intervals for the log hazard. Okay, so if you want the 95% confidence for hazard ratio HR, then that's it for you lah. 0.7462 and 0.8463. It means that if in a population where GCS is 1 unit higher, for example, if you compare GCS patients of 14 versus 13, then the hazard to die for those who has 1 unit higher GCS will be between a factor of 0.746 to a factor of 0.846. Or you can interpret that if GCS is higher by 1 unit, then the hazard to die will decrease by from 16% to 26% at 95% confidence level. Okay, so think about it. Not that hard. A bit confusing lah. If you have interaction term, it's also similar to what we did before. This is a model with no interaction. So I'm giving this model name as cox.gcs.h.no IA, no interaction. Okay, so easy for me to understand lah what is the model for. So I'm gonna put here, and p-value kena tengok tak prof? I mean, why so obsessive with p-value, right? Why so obsessive with p-value? P-value not important at all, right? Okay, we'll come back to that later. Okay, but p-value is the last thing you want to see. Okay, the last thing you want to see. Okay, the last thing you want to see. Okay, so after we are very happy, then we look at p-value. Now p-value is letak tepi dulu. Okay, letak tepi dulu. What more important is how meaningful the interpretation, how significant the interpretation, rather than looking at the p-value. So now a model with no interaction. Okay. We got GCS. We think that GCS, we think that age, diabetes, hypertension, can affect the hazard of dying. Then that's why we developed this model, and we want to name this as Cox GCS age no IA. I think this will create error here because we'll see. Okay, we'll see what happened. Okay. Oh no, come out. Okay, that's good. That's good. Okay. In fact, I can use DM here, but I'm using DM2. DM2, but it works because I have oh yalah, because the variable tu memang dah DM2. Okay, good. No problem. Okay, sorry for that. Okay. So this is a multivariable model where we do some adjustment for some other variable. So in this case, whenever GCS increase by 1 unit, in a model that we adjust for age, diabetes, and hypertension, the log hazard changed by a factor of minus 0.22. When age increased by 1 year, in the model where we adjust GCS, diabetes, and hypertension, the log hazard increased by 0.022. In the model where we adjust for GCS, age, and hypertension, if the patients have diabetes, then the log hazard to die will change by a factor of 1.08, so on and so forth. Okay, and this is the value of this, the log hazard. This is the hazard ratio. Okay, so if you have diabetes mellitus, if the populations have diabetes mellitus, if we adjust for GCS, age, and hypertension, the risk or the hazard to die will be 2.93 times higher than those without diabetes mellitus. All right. So if the patients,
Macam mana dia first decide nak masuk GCS dengan age tu? Ke just for example je dalam model?
Again, that will depends on the methodology of the researcher lah. Macam mana you nak include JCS and age. So that is nanti because this is statistic kan. So we are not going to kata discuss in detail macam mana kita add GCS, kenapa kita add GCS or age. Tapi the why we choose this one, kita dah discuss masa kita discuss about the bias, confounders, mediation, moderation ni kan dalam EPIC tu. In real life, when you do the study, you have to combine both kan. Tapi dalam statistic class ni, I'm very simply I choose this because I think that GCS, age, diabetes, hypertension might have relationship dengan probability of dying from stroke. That's the main motivation. Okay.
Prof, kiranya macam based on researcher sendirilah kan, Prof kan?
Yes,
kita decide
yes.
masuk ke dalam main effect model tu, and then baru kita compare, kita tengok interaction semua tu lah. Tapi untuk main effect model itself memang based on researcher lah, decide which one yang
based on your research. Yeah, to decide what would be your workflow, what would be your decision to do that. And when you said to decide, you decide based on what? Is it based on just literature review, or is it based on literature review plus screening of variable, or and so forth lah. So that have to be clear cut, and there are many ways of doing that. The one yang kita selalu sebut, yang kita kata p value of less than 0.25, do some screening, and after that if it is less than 0.25, I will include in multivariable analysis. That I think is too simple for us. Okay, too simple for us. So for you, I think for your DRPH thesis especially, the process must be a little bit more robust lah. Tapi I'm not sure whether that's fair for you lah. But you know, think about it, right? Think about it. So what else? So okay, now with interaction. So I thought that, you know, maybe we think that maybe GCS have got some interaction with age. You know, the older you get and the more severe GCS, then maybe that will affect the survival probability. So based on that, you know, very simple assumption, then I put it as interaction. So I'm going to name this as COX GCS HIA. And again, if you want to challenge me to say that that's wrong, then yeah, you are correct. Okay, I think that, you know, my model is like this, then your model is also correct and my model is also correct from my perspective and your model is correct from your perspective. Or maybe both of our models are wrong, like Josh Box says, but between the two of us, which one is more useful? Right, so we run this. There is an interaction here, so there is a colon here to say that there is interaction term between GCS and age. Then we'll type summary and put the cox GCS age interaction, and now you have to be careful because you can not anymore interpret like before. Because there is interaction between GCS and age, you can interpret diabetes like before, you can interpret hypertension like before, but you cannot interpret GCS and age like before. So you can say that in the model with adjusted for GCS, age, and interaction between GCS and age, if you have diabetes, then the risk of die will be 3.04 times higher than population without diabetes. If you have hypertension, then the hazard to die could be would be 0.52 times lower, or 0.52 times the hazard of those without hypertension. So if you see here, then you say, alamak, how can it be? If you have hypertension, okay, if you have hypertension, then from here it says that there is a 48% lower hazard for you to die. Okay, compared to those with no hypertension. It means that, you know, the lower hazard or lower risk to die if you have diabetes. If you have hypertension. Again, this is the what we call as the effect of adding variable. Okay, so maybe there is some correlation between diabetes and hypertension, and because of that, it makes this a little bit complicated. So, you know, so be careful how to interpret this, and people will ask you, okay, why you say if you got hypertension, there is lower risk to die? You have to be prepared with that. GCS and age, you can't interpret like that because you have to consider the interaction term here. Model comparison. Okay, you can compare the two models. You can compare the two models using ANOVA, analysis of variant functions, but test is chi-square. So this is basically not an ANOVA test, but this is a likelihood ratio test that compare the variance of the two models. Okay, so it compared the two models, model with interaction, which is this one, and model with no interaction, which is this one. Do comparison, and the chi-square value is 1.8, and degree of freedom is 1, and the p-value is 0.17. So if we set the p-value of 0.05, then we can say that with level of significance set at 0.05, then there is no statistically difference between model with interaction and model with no interaction. So in that case, how will you decide? Would you take model with interaction, or will you stick to model with no interaction? Maybe you say that, okay, since there is no difference between model with interaction and between model with, so if there is no difference between model with interaction and model with no interaction, then I take the simpler one, which is the model with no interaction, because there is no difference. You can do that. Okay, but again, p-value is a trap, so then don't fall into the trap. since we did Cox proportional hazard regression, very, very important that you need to test the assumptions of proportional hazard. There is a test called Cox.zph. And then since we say that, okay, I'm going to take the model with no interaction, then the model here is the model with the no interaction. The name of the model that we chose, which is the Cox.gcs.h.no.ia transform KM global true. The global is the overall test of the model. Okay, so the global test there is 1 point. The chi-square is 1.76 with p-value of 0.78. If we choose the level of significance at 0.05, then we can say that there is no evidence to suggest that there is violations of proportional hazard assumptions. So because of that, the proportional hazard assumption is met. Okay, is met because the p-value here is not significant. Then it is valid for us to use Cox proportional hazard regression. Okay, the question would be, what if the p-value here is significant? Then we go and discuss this next week. Right. Okay. So, yep, that's it. That's the short practicals. Okay. Any question? Tak apa, we still have one more week to revise it. I'm not sure what we're going to do next week. So maybe we are going to do the same thing or what? Because this is your first time learning survival analysis. So I think we better give you 2 weeks lah rather than 1 week. Linear regression, I think you are very comfortable. Logistic regression pun maybe you are more comfortable now. Survival is something new for you. So I believe you can if you not that tired lah, you still can go on, then you can slowly do long practicals today ataupun tomorrow ke, and do in RStudio Cloud, so that I boleh tengok lah siapa yang dah buat, siapa yang tak buat lagi ya. Alright. Any question?
Prof, jangan nak tanya pasal kalau model with interaction tu tadi Prof, macam GCS with H kan. Yang tu kalau nak interpretation ni, kita nak interpretation mana kalau nak GCS saja tu nak tengok macam mana, kena sekalikan dengan interaction tu atau kita nak combine ke macam mana Prof?
Jadi kalau ada interaction gini, then kita kena split lah. Then what we can do is we have two choice. Okay, we have two choice. Okay, so if there is kejap so saya pakai mana delete button? Keyboard baru tak jumpa delete button.
Kat atas Prof, atas kanan.
Tak ada delete kat sini. Mana ni? Sebab saya pakai keyboard baru kan. Keyboard ni tak ada ni. Keyboard mahal sikit. Alright, so okay, so if there is interaction, okay. No? Yes. No is okay lah, not bad, okay? So if you have yes, then we have two options, okay? First, we stratify, means that we do Cox. So we have age dengan GCS, right? So we can split GCS into maybe three category into maybe low GCS, moderate GCS, or good GCS. So we do the same model first in low GCS, second in moderate GCS, and third in the good GCS. So in that model, we don't have interaction anymore. We just we replace so in the covariate will only have variable A plus B plus C. Tadi ada A plus B plus C plus H GCS. Now we have only H. But we need to do for low, moderate, and good. Secondly, we can do what we call a stratified Cox regression. In this one, you still include A plus B plus C plus H time GCS, but you do a stratified Cox regression. I'm not sure whether I'm going to talk about this next week ataupun I'm reserving this to epic group sahaja. I'm not sure about this. I forgot, nanti I tengok balik. So in this example, in this stratified Cox regression, we the algorithm or the estimations or the process will make this as an average. And then but the disadvantage of doing this, that you will not be able to estimate or to see the effect of this, because it is sort of kata apa, dia averagekan benda ni, and then dia akan bagi value log hazard for A, for B, and for C. This one you have to do manually. Split your data. It means that from your data tu, your data set to split into data 1, data 2, data 3, and then run the same model here. But this one, you still work with your own one data. You just use a functions to call for stratified Cox regression. When you see the result, there is no more age and GCS. You will have only other variables. So there is, some one major disadvantage lah for stratified Cox regression, but this is much easier to do. Satu lagi is if there is interaction between like this, you can split this half, then do model Cox for this and do Cox for this. For example, let's say this is age, then ambil the cutoff point where it's split there, then do Cox for between this and this, and Cox between this and this. So you got two Cox regressions. Any other question? Tak ada jawapan clear cut tu, Kudin.
Okay, bro. Tapi nampak dah sikit. Kalau
Alhamdulillah. Okay, saya pun tak pernah buat sampai ke sini lah, stratified Cox ni. And yeah. Any other question? Tak ada? Okay. Kan ada dalam chat lah. Tengok kejap chat ni. Kat mana? Tak ada. Okay. Alright. Okay, then so saya rasa minggu depan mungkin kita akan practice the same thing. Kalau rajin tu boleh tengok stratified chords regression. Stratified chords regression dalam buku Kaplan-Meier yang agak clear in terms of interpretation. Dalam buku Hosmer-Lemaitre as applied survival analysis tu not that clear. Okay, not that clear. So if you want to refer to stratified chord regression, then baca Kaplan-Meier punya survival analysis punya buku yang tebal tu lah. Okay. By the way, you baca nota apa untuk logistic regression dengan survival analysis ni? Buku apa you refer to?
Saya dulu baca nota sendiri je masa buat tadi.
Okay. Which is clearly not enough lah. You kena baca. Bukan kena baca, kena ada buku Kaplan-Meier dengan Hosmer-Lemaitre tu. Semua dah ada ke buku Kaplan-Meier dengan Hosmer-Lemaitre tu?
Ada bro.
Sebentar.
Jujur juga.
Okay, ambil dengan Hidayat lah apa ni, soft copy Kaplan-Meier dengan apa ni applied survival analysis daripada Hosmer tu. Baca sekali memang tak faham lah. Baca 2 kali faham sikit. 3 kali faham sikit lagi. 4 kali faham banyak sikit. Okay. So tak ada apa-apa So kalau gitu kita boleh stop kat sini. Nanti saya nanti saya nanti bagi link untuk video ni dengan video yang last week. Saya dah bagi tu, saya tak bagi tu sebab saya sama je dah bagi kan, tapi rupanya silap. Okey, terima kasih semua. Okey, Assalamualaikum. Selamat menontonlah malam ni ya. Doakan kita menang banyak.
InsyaAllah.
Thank you, bro.
Bro.